Hi everyone! Today we are going to be learning about terms and answering the essential question of what are like terms. So in our lesson today we are transitioning into algebraic expressions. So algebraic expressions are expressions that have numbers, letters, and variables. And so when we're looking at terms are the parts that make up the algebraic expression. So terms, they make up the algebraic expression. So these could be things like constants, coefficients, and variables. So there's all these different things that go into making up the terms. So the terms are the parts. When we're looking at the terms, let's go ahead and write an algebraic expression. So an algebraic expression would be something like 4x plus 3 plus 2. Okay? The parts that make up the algebraic expression are each of these things. We have a coefficient. It works together with the variable to create a number. We have the constants and another constant. Okay, we also have the variable of x. All of these things are terms. Each one of these is a term. Without these things, we would not have the algebraic expression. So our question that we're looking at today is like terms. What are like terms and how do we find like terms? So I'm just going to scooch this up and let's talk about things that are the same. So like terms have variables that are the same. Again, still terms. So terms, each of these parts, but they are the things that are the same variables and same exponents. So terms will have the same variables or same exponents. Okay, so they're the terms that have the same variables or the same exponents. Like means the same. Okay, so these would be things like if we had the algebraic expression of, I don't know, 2x plus 3x plus 4, the ones that would be the same are right here. They both have an x on them. This one doesn't have a match. There are no other constants here. So let's do an example of like terms and then go from there. So if you need to finish writing up either the terms or the like terms, go ahead and hit pause right now so you can finish your vocabulary. But we're going to move into our first example. So example A. All right, example A. It says to rewrite the sum of the terms. So the first example we have is 9x minus 2 plus 7 minus x. Okay, so our job is to first identify what are the terms. So we're going to identify what are the terms, and then we'll look at the like terms. So the terms are each part of this expression. So each part of the expression. So 9 and x are stuck together. They are a term, 9x. This would be a positive 9x because there's nothing in front of it that shows us it's a negative. Another term that we have is right here. This one, we keep the sign with it. -2 is the next term. Another one we have is this. We have a +7. So a +7 would be the term. You don't need the positive sign because a 7 on its own is just a positive. But I put it there so you could see it. And then the last part that we have is this x with the negative. So we have a -x. Each of these makes up this algebraic expression. So each of these are the terms. So we're going to figure out what the like terms are. So like terms have the same variables or same exponents. So our like terms are the things that are the same. Like terms. So like terms would be, the first one we have is this x here and this x here. This is like having a 1x or a -1x. So like terms, we have 9x and we have -x. These are one set of like terms, and that's because they both have the x on them. Another set of like terms is this -2 and this 7. They're both constants. So -2 and +7 are both like terms. They're like terms because they both are just numbers. They don't have anything attached to them. So 9x and -x are a like term, and -2 and +7 are both like terms. Okay, let's do another example. So our next example, example B, looks like this. We have z² plus 5z minus 3z² plus a z. All right, so first of all, let's look at the terms. So let's go ahead and look at the terms that we have, and we're going to just start shaping things together. So I'm going to do this one just a little bit differently so that you can see it. Okay, z². That's the first one, is z². So anywhere I see a z², I'm going to put an orange box. So z², and this z² is attached to -3. So both of these are terms. They're both terms. So z² and -3z² are both terms. They make up this algebraic expression. Another term that we have is 5z. 5z is a term, and a +z is also a term. So the terms that we have here are z², we have 5z, we have -3z², and we have a +z. Now we're going to look at the ones that are the same. Same exponents, same variables. So the ones that go together for like terms are the ones that have The like terms, we're going to put the z squared together. So both of these are the same because a negative 3z squared, because they both have a z squared. Okay, they both have a z squared. So they're both going to go together. Sorry that my dog keeps growling in the background. She's sitting right here being obnoxious. And then we have these other two. They're not the same. Yes, they both have z's, but they're not the same. And they're not the same because this does not have a squared. So 5z and 1z are the same there. So these are like terms, and these are like terms because they both are squared. So this has two sets of like terms. Okay, we're going to do another problem, and this time I want to do one that just has one set of like terms. So we're going to do example C. Here we go. And on example C, this one is only going to have one set of like terms. So example C, we have 3y minus 2 minus 4y. All right, so on this problem, we're going to list the terms again. So here's a y, here's a y, and then this 2 is all by itself, and it's a negative 2 because we keep the sign with it. So the terms, it has three terms, 3y, negative 2, and negative 4y, but like terms, it only has one set of like terms, the 3y and negative 4y. Those are the same. This constant is all by itself, so we wouldn't need to worry about the constant. So we're just identifying the terms and the like terms. All right, it is your turn now for 2 try-its. So we're going to give you 2 try-its to do. And of course, one of the ones they gives you has a fraction, and that's okay, doesn't matter. All right, so try-its. Here is try-it number 1. Try-it number 1, you have y plus 10 minus 3 over 2y. I want you to identify the terms and the like terms. And then try it number 2. Try it number 2. Oh yeah, let's do this one. Try it number 2 has some exponents in it. Is 2r squared plus 7r minus r squared minus 9. Okay, go ahead and hit pause right now so you don't hear me solving. And then when you are ready, come on back and check your level of understanding. All right, so first we're going to identify the terms. So the terms, there's a y, and there's a y. I'm going to go ahead and start looking at these in colors. So my terms are y, 10, and negative 3 over 2y. The like terms are both the ones that have a y. So my like terms are y and negative 3 over 2y. It is not the 10. The 10 is not the same because it is a constant and it doesn't have a y attached. So y and y. Only one set of like terms. Okay, let's look at the next one. over here, r squared. There's an r squared. And then, ooh, this one's a little bit different. This one is a 7r, and it also has a -9. So the terms here, the terms are 2r squared plus, oop, no, a 7r, a -r squared, and a -9. Those are the terms. The like terms, again, this one only has one set of like terms, and it is the one with the r squared. We only have two colored. So 2 of the same color there. So 2r squared and -r squared. Those ones are the same because they both have an r squared. This one is not the same. It's only one r, and this one does not have an r at all. So that one doesn't work. All right, go ahead and answer your essential question. How do we find like terms, or what are like terms? And then when you're finished, go ahead and put your level of understanding out to the side. Where are you at with finding terms and like terms? What is the difference between the two? And then when you are finished, you can either come on back to the Google Meet and ask for help, or you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.